Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss about free liquid jets. So this free liquid jets is actually, if you see, here I've taken a diagram of this. Okay, so the free liquid jets is defined, you can say, the jet of water which is coming out from a pipe of nozzle and to the atmosphere. Suppose this is the pipe is there, you can see, this is the pipe, and in the pipe there is a nozzle is connected here. So the liquid which the jet of water which is coming out from this nozzle to the atmosphere, so that we can say that is a free liquid jets. Okay, and if you see the jet which is traveling from the air, suppose the jet of water which is coming out from this nozzle, and it will be is going to be a atmosphere. Up to a certain distance it will be move, it will be go high, and after that you can say again it is started falling down. So the curve, the path which is continued by this jet of liquid, if you draw a arc on that or draw a line on that, you will get a parabolic in structure. Okay, so here I have taken a pipe where I as I told that let's consider the jet which is coming out from this pipe, not pipe, from the nozzle. So this is, say this is the pipe and this is the nozzle part, this one. Okay, and now let's consider the velocity of jet is u. So let me write here, let's consider the u is the velocity of the jet of water, and similarly when it is traveling in this, it is a moving, if you see some angle is there, and that angle is theta. So theta is the angle between the jet of liquid and its horizontal component, horizontal direction. So that is theta is there. Now when it is moving in the angular movement, then we can say this liquid will have two components. One is horizontal component, another one is vertical component. Okay, so this liquid, if you resolve in two different directions or two different components, then we can say this is which is moving in the horizontal direction. So that can be written in u cos theta, and this is in the x direction, and the next one we can write u sin theta, which is moving in the y direction. Okay, these are the two different components are there. And now in this movement, let's consider another one point. See, in this path means like when the liquid is started like this and it is moving, and again it will reach a maximum height as I told, and after that it will be started falling down. Now in this, consider a point P here and give the name of P, that is xy. Some distance will be there, like some value will be there at this point. So what is the value at this point P? So how much distance traveled from the x direction and how much distance traveled in the y direction. Okay, so it is very simple. So here from this and starting point, what the distance traveled, now suppose it is x, and what the distance is traveled here, suppose that is y. That's the same thing it is mentioned here. Now yeah, so the coordinates, you can see the coordinates of P, as I told you, that is P xy I have given, and the velocity which is moving in this, let's consider from this point P point, let the fluid which is moving in the horizontal direction, that is u, and which is moving in the vertical direction, that is v. Okay, so these are the two horizontal components u and one horizontal components, one vertical components at the point P. This one, this is u and this is v. Okay, now what we'll do, so this one we need to find, okay, that distance traveled, what is the distance traveled at this point, okay, along the x direction, along the y direction, that need to be calculated. So let's find out the horizontal and vertical distance traveled by the liquid, okay, at the particle with respect to a time t. So for this I can write, as I told you, the distance how much traveled here from here to here, so that is x. So x I can write, what I can write here, from how much distance is traveled. See, if I take horizontal distance, I can say it is x, and plus of x, I can put the value of u cos theta. But if you see the position of this P point is, somehow angle is there, inclined is there. So that's one how we can calculate, how we can write. So this is x equal to, I can write the velocity component in the x direction, into t. So this is the meaning of, we know that if I tell you how it came now, if I want to write, then I can say we know that velocity equal to what? Now what is the velocity of the liquid? Now how much distance traveled and what is the time changed? Okay, what is the distance traveled by the liquid and what is the time taken for that? So similar from here I can write, dx equal to your velocity into time dt. So same thing I have written here, x equal to the distance traveled equal to what is the velocity of the fluid and what is the time taken. The same thing I have written. So here again I can write what is the velocity of that velocity component in the x direction, that is nothing but in the x direction, if you see, that is u cos theta into the time taken t, and this one, this is your x value, and here I can give a equation 1, and this same equation also I can write in such a way, what is the time taken for that equal to this distance traveled by the velocity, that is u cos theta. This also I can write. Similarly, this is in the about the x direction. I hope you understand. Now similarly, we need to find out the distance traveled in the y direction. So same thing again I can write y equal to the velocity component in the y direction. Okay. Now here in this y case, we need to write the velocity component in the y direction into time. Again, we need to minus, or we need to subtract the, we know one formula that u equal to ut plus half at square to find out the components traveled, which is when it is traveling the vertical direction, because in the vertical direction we have an impact of edge. This is there, velocity into time is there. Again, along with that we have a half at square will be there. That means what is the time taken and the acceleration due to the gravity. Okay, so that because when it is moving in this vertical direction, there is an impact of gravity on the fluid, which will try to take the fluid always downward. So that will be considered. So for this case, what I can write here, what is the velocity component ut? The same thing here. I can write here velocity component, that is u sine theta into t, and half at square. That means we can write here due to the gravity which is acting here, so that movement will be downward direction. Okay, so that we need to consider minus, negative sign. If it goes upward, then we have maybe taken positive direction, but due to the gravity impact is there, that's why I'm writing negative term. So that is half, and acceleration due to the gravity, so I can write half gt square. So this is the equation for the vertical components here. Now this one we can give again, we can write here. Now if you see previously, as I got here t value here, so what I'll do, I'll put the t value here in this equation. So I can write u sine theta, what is the value of t? X by u cos theta. Correct. Now u cancel. Now again half gt square is there, g into x square divided by u square cos square theta. Now finally what I can write here, this equation, y equal to, I can write this sin theta by cos theta, that is tan theta. So x tan theta minus, here I can write 1 by 2 g x square, this is u, okay, u square cos square theta. So this one again 1 by cos square theta, we can write here also sec square theta. So that also you can write here. Again, if you want to write, change it, we can write x tan theta minus gx square by u square by u square. Here it is sec square theta. So that is nothing but 1 by cos square theta equal to sec square theta, we know. So this one we can give equation 2. This is equation 2. Yeah. Now if you see this equation gives the, the variation of y along with the square of x, That means the distance traveled here. If you see now what is the distance traveled here, this is, you will get a parabolic structure. What is the distance traveled? Now up to here we have taken. If you take up to some other distance, this will be extended. So this is the double of this x, the value. So now here what will get now, y value or y point, double of this x value. So at this condition we can get a parabolic structure. So the jet which is going to be traveled and it is going to be complete its path, so it can consider that is a parabolic structure. So this one point we got from the equation. Now from this equation we need to find what is the maximum height attained by the jet. Now we'll go to the next page. So here what I'll write, the next point will derive what is the maximum height, attained by jet. So, or we can say what is the maximum height traveled by the jet. So here what I'll do, I'll consider the equation what we have studied, u square minus v square equal to 2as. This equation we have studied. So here from this equation, okay, I'll consider the value, the relation I'll consider here, what is the maximum height, what is the final velocity is there. Suppose the final velocity v2 square minus initial velocity v1 square equal to 2as. 2as is nothing but 2 acceleration due to gravity and s is the distance. So now here on place of acceleration due to gravity, because as the gravity impact is there, again I need to consider the negative sign here. So that is nothing but minus 2gs. Okay. So here if you see the velocity v2, okay, that will be 0. Velocity v2, so that is 0. And so what you can write, this equation put this value. And what about the v1 value? Now v1 value we have seen, v1 is nothing but what I'm talking about, that is u1 or u. So that is in this. Now see, here we have taken on the x direction, but now I'm considering in the y direction. I'm considering only y direction. Why I given the name of v1 and e1 because v1 and v2, because here already we have taken u and v part. Okay, so here I've taken different velocity component here. So what is the maximum height it is going to be traveled by the jet? So that's why I'm taken two different velocity here. Now v1 is the final component, and v1 is the v2 is the final component, v1 is the initial component of the jet. So that will be, you can write v1 equal to u sine theta. So this, put this value in this equation. So what will get here? And this negative sign, as I told you, due to the gravity which is acting always downward in direction. Okay, and but the particle is, see, fluid is supposed to moving up, but this fluid having some impact, weight impact is there, and that the gravity, due to the effect of gravity, it's trying to be vertical downward. So that's why I have taken this negative term here. So what I can write, that is 0 and minus u square sine square theta, u square sine square theta, and this is equal to minus 2gs. So this s is the maximum vertical height which can be traveled by the fluid. S, as I told you, the distance, that means what is the maximum height can be traveled by the jet. So here if you want to write, because the maximum height I need to be identified, so I'll keep s one side and remaining term other side. So it is minus of u square sine square theta. So I'll write only u square sine square theta, because negative term I can cancel here, and u square sine square theta by 2g. So this is equation 3. Okay, the next part is this is one point. Second point, let me find out. Okay, what is the time of flight? What is the time of flight for this? Okay, so the time of flight is nothing but the time taken by the fluid particles to reach a point. Suppose, you know, the point A is here, okay, and it will take, suppose we'll take, consider a point here B, or somewhere you take the point B. So what is the time taken for the liquid to reach from that point to from A point to B point? The B point may be anywhere, we can consider that one. So what is the time of flight is, that is already T, I have to consider for that. So for this, if you see the equation, previous equation, what we got here, this equation. So from that equation, what I can write, okay, this one need to be find out. So to find this one, let me consider what we got, y equal to u sine theta minus half gt square. This equation we got already previously, we have written. Now this is our main equation. Okay, now when the particle reaches at final point, if you see, when suppose a particle is there at the final point, okay, and here if you see, the y value will be 0. There is no movement in the vertical direction, only x direction is there, correct? So when the y direction, no movement is there, only vertical, horizontal direction, it is closed here. And the time taken, initially suppose you started from here T, and the time taken at here, let's see, capital T. Just put this value in this equation, we'll get that. So y equal to 0, and this is u sine theta, and this is minus, we can write half gt square, capital T, on place of small t, I have written capital T. Now what I need to find out, I need to find out the capital T, the time taken. So what I'll do, I'll just take it to this side, and here I can write u sine theta, and this will be, when it will go this side, half gt square, then again half gt will become this side, then that will be 2u sine theta, 2u sine theta by g. This is equation 4, another equation for the time of flight. This is the maximum height traveled by the jet. Now we'll come to the third point. Third point is nothing but time to reach the highest point. What is the time will taken to reach the highest point? I'll go to the next page otherwise. Yeah. What is the time to reach maximum point? Maximum point. This is simple actually. What is the time, maximum time? What is the time will taken? So that one, this one will take t star. Already t we have taken. So here let t star. So this actually concept of the time to reach the highest point is the how to find out to half of the time of flight. So what is the time of flight what we got? So same thing what I'll write, just very simple, t star equal to what is the time of flight taken divided by 2. So 2 will be cancelled, because in the previous equation if you see 2u sine theta by g is there. Now this of half, so we'll get u sine theta by g. Now the next point is, we'll find out what is the horizontal range of jet. What is the horizontal range of jet? Horizontal distance already we have taken in the x value. So here we will take x star. So this x star is nothing but, we can say, the total horizontal distance traveled by the fluid particles. If you see the distance traveled by the fluid particles in the horizontally, okay, and from here to here, x already we have taken from up to here only. So the total distance in the horizontal distance, if you see, that we can take x star. That is the only thing, nothing extra here in this. So for that x star, we need to find out what is the component which is traveled in the horizontal direction, okay, and what is the time of flight. So you can write x star equal to the component in the x direction, okay, into the time taken to reach, what is the time taken to reach from A point to B point. Let me tell you. See the total component in this x direction and what is the time taken from here to here. Simple, as we are initially found that one. So that is nothing but u cos theta into the time of flight or the time taken. So that is nothing but 2u sin theta by g. Just now we have calculated this one. So I can write x star equal to u square 2 cos theta into sin theta by g. So this one, you can 2 cos theta sin theta, we know that sin 2 theta, so you can write u square by g sin 2 theta. Now up to 4 equation we given, so this one we can give equation 5 and this one we can give equation 6. Just to remember these points, it's very simple actually to find. These things we have already studied in our previous higher secondary one, and here also you can apply in the fluid mechanics. And what is the value of theta? What is the value of theta of a maximum range? That means how much theta can be taken at what range. So that is nothing but we can write x star max. So this is the range of, the range of x star will be maximum for the velocity of a projection u when this sin 2 theta is maximum. When it is maximum, then this will be going to be maximum. So value of theta for maximum range. Value of theta for a maximum range. That means x star max. So that how we can calculate this one. Now when it is maximum means sin theta, we can write sin 2 theta, maximum means 1. Okay, and here we can write sin 90, we can write sin theta equal to sin 90 degree, because we know that sin 1 equal to, we can write sin 90. Now here I can write 2 theta equal to 90 and theta equal to what? 45 degree, 90 by 2. So this is 45 degree. So the maximum range, what will be the maximum range? So that we can write x star maximum equal to, for the equation we got there, the same equation, right? U square by 2 and this is sin 2 theta. So to sin 2 theta equal to 45 degree. So here if you put the value 45 degree, sin 2 theta that is 90 degree. So sin 90 we will get 1. So you will get u square by 2. This is equation 7. So this is the value of theta for the maximum range of Okay, so these are the things I supposed to discuss with you. So now see, from a free of liquid jets, what are the points came out to discuss? Okay, when that liquid is traveling from a nozzle of pipe and how it is traveled and what is the time of flight, how much time taken. So all these things we have calculated here. Now see, first point is for us, that is the maximum height attained by the jet. Next one is the time of flight. Okay, and third one is the time to reach the maximum point, that is T star. What is the time will be taken to reach the maximum point, and what is the horizontal range of the jet, horizontal distance, how much, and what is the value of theta for a maximum range. So these are the points we have discussed today lecture. I hope you understand. If you are having any kind of query and doubt regarding this, you can give a comment on the comment box. Thank you all.